Hello students, welcome to CMI's online classes, and this video is for class 6 chapter number 10 measurement of distance and motion. So in our first two videos we talked about measurement of length, or you can say distance. We talked about its units, we talked about its correct measurement, okay. And now today in this video we will be discussing about motions, okay. So what is motion? First of all, you may have wondered that when you see or when you go to market, every objects keep on moving. As for example, the peoples are moving, okay, the animals are moving, dogs, okay, dogs are there, cows are there, buffaloes are there, even you see movement of an vehicles also. Okay, so movement or motion is said that when it moves with respect to certain point or time, we call it a movement or a motion. Okay, as we know, we people move, but even plants also show some type of movement. Okay, they don't locomote, they don't move from one place to another, but they shows movement. Okay, so we will talk not about plants or animals, but we will talk about motion in this chapter. So an object is said to be in motion if it changes its position with respect to its surrounding in a given time. As for example, you are there, okay, and your friend is there. You are still at point somewhere, and your friend moves towards north, okay, and at some time, because you say you can 10 seconds, after say 10 seconds your friends move from that point to another point. So that is called motion with respect to the initial position and time. So motion is always observed and measured with a point of reference. So it is always observed. That means if it moves, we can say that it has moved from this place to that place, and measured with a point of reference. That means point of reference, I told that you and your friends are standing in one point, okay, a known landmark, okay, and if your friend moves, you will observe motion. So all living things show motion wherever, whereas non-living things shows motion only when some force is acting on it. So all living things move, they show motion, whereas non-living things like car, okay, the benches, or car benches, and you can say the flower pots, then we have the TV, fridge, whatever. If you move from one point to another point, okay, so some force is acted on it, okay. If some force is given, then only it changes its position in non-living things, okay. That means man-made things, but all living things, those are natural, they shows some motion, okay. Now let's talk about rest and motion. We talked about motion, but before that, before motion, we have to know what do you mean by rest. So we must know what do you mean by rest, okay. So let's know what do you mean by rest and motion. So rest, an object is said to be at rest if it does not change its position with respect to its surrounding and time, okay. Similarly, an object is said to be in motion if the position changes with respect to its surrounding and time, as we discussed earlier. So as for example, you and your friends are in say in a school, okay. and you have to move. Okay, so your friend have to stay at school on the gate only. Say his or her parents are will come to receive her. Okay, so she is still there, and your home is not so far, so you can go by walking, okay, by yourself. So when you move, you are in motion and your friend is said to be at rest. Okay, so similarly we can figure out by giving other example also. You are standing on the side of a road, and you have to go to some far other places. Okay, so many cars keeps on moving. Okay, you are stagnant there. Okay, you are at rest, but the other cars keep on moving, and that is called, the car is in motion but you are in rest. Okay, so rest means sleeping, sitting, okay, even standing also. And motion, we have an example of running, cycling. Okay, here cycle along with the boy is in motion. Okay, so now we will move to rest and motion are relative. That means they are synonyms to each other, or they are common to each other. As for example, we talk that rest, when an object doesn't move with respect to time, is said to be at rest, and when an object moves with respect to time and its surrounding are said to be in motion. But let's have an example here, how they are related. A person sitting in a moving train is at rest with respect to his fellow passengers. Okay, that means if you have observed carefully, and so I was talking that if you are in a train, okay, many people are sitting there, and with respect to the other passengers, they are still in rest, but it is in motion with respect to the object outside the train. That means those who are looking the train from the outside, the train is in motion, but the person sitting inside the train is at rest with respect to other passengers. Similar is the case with car also. In car also, many people are there, they are not changing the position. Okay, but the other people who are looking at the car is in motion. So they are relative. So, but in the motion with respect of the object outside the train. So this is the situation when object in one situation can be at rest, but in another situation the same object is in motion. That means if we consider the person sitting in the train or in the car is at rest because they are not moving, they are still in rest, but the same object when viewed from outside, okay, so it is in motion. So they are relative. Now let's move to types of motion. So are all motion alike? Means the same? No, motion are different from each other. Some are in a straight line, some rotates, some are having a certain period, some are very fast, quick. Okay, so looking at all the factors, we have categorized 6 types of motion. Number 1, translatory motion. Okay, so in translatory motion we have linear motion or rectilinear motion, we have circular motion, and we have random motion. Okay, same. Another we have rotatory motion, that means rotation. Then we have rolling motion, the movement of rolling. Then we have periodic motion. That means the motion is of certain period. We have oscillatory motion. That means like oscillation, like a pendulum. Then at last we have vibratory motion. Okay, so we will talk about translatory motion. So what do you mean by translatory motion? Okay, so as we know, the motion in which all points of moving body move uniformly along a straight line is called translatory motion. That means the motion is in uniform, okay, and in a straight line, okay, and they are called translatory motion. Example, we have the motion of a car. Okay, it moves in a straight line and it is uniform. Then cycling. Okay, a cyclist in a straight road, cycling in a straight road, you have seen that it's move with the same velocity of same speed. That means it is in motion, uniform motion, and it is in straight line if there is a straight road. Then we have a falling apple as an example. That means it moves or it is dropped from the tree to the ground uniformly or in a straight way. It's not that it comes to far away from the tree, okay, and that is due to gravity. Okay, so these are all the examples of translatory motion. Now let's talk about different types of translatory motion. So we have first of all rectilinear motion. Rectilinear means in a straight line. If a body moves in a straight line, it is called a rectilinear motion. Okay, that means if the road is straight and if a certain object is moving in a straight direction, it is said to be a rectilinear motion or rectilinear motion, whatever. So example, we have moving of a car along a straight road. Okay, as we can see the figure on the left lower corner. Okay, shoulders moving in a straight line during parade in 26th January or 15 August. Even student also parades. Okay, so they move in a straight line. Are example of linear or rectilinear motion. Okay, we have various other examples also. Okay, you can find it out by your own. Now let's move to curvilinear motion. So same, if a body moves along a curved path, then it is said to have curvilinear motion. That means in a curved path. Okay, if the road is not straight, if it is in a curved shape, okay, so you can say the body moves along a curved path, so it is moving in a curvilinear motion. Okay. Example, we have motion of a car along a curved road. Okay, not in a straight road, in a curved road, as we can see mostly in the hill areas. Road in the hill areas, they are mostly curved because the road has been cut due to road has been made by cutting the forest or the mountains. Okay, and mostly the roads are in a curved shape. Okay, we can have a good example in hill areas. Then we have a ball, a giant wheel. Okay, that you can see in a fair or in a mela. Okay, it is also in a curve motion. Then we have another example, you can say throwing of a ball, okay, in a ground. If you throw a ball to your friend in the sky, it will make a curve motion. Okay, the ball will move in a curvilinear motion. So these all are examples of curvilinear motion. Then let's move towards circular motion. What do you mean by circular motion? curvilinear is different and circular is different. Curvilinear means it is curved, circular means it moves whole. Okay, so an object is said to be in circular motion when it moves around a fixed point called axis. So there is a point called axis and the object move around the axis. Okay, we can have an example of rotation and revolution of the earth. Okay, so rotation of the earth, as we all know, earth rotates in a fixed axis. Okay, that takes almost 24 hours. Similarly, it revolves around the sun. So both the motion are said to be circular motion. Similarly, on the right lower corner, we have merry-go-round. That also you have mostly seen in some fairs, melas. Okay. So here a fixed pole is attached in the middle of that playing thing. Okay, and on the side there is a sitting post. Okay, children can sit there. So the middle axis is fixed, and the children who are sitting on that what you can say, the toys, okay, big toys, they keep on moving round and round, and that is a type of circular motion. Okay, so we have a rotation and revolution of the earth and merry-go-round. Other examples are also there, but I have only given 2 examples for explanations. Okay, then we will move to